Audio Jungle.
Okay guys, up next we would like to learn about work and dissipative forces. In previous examples, we have seen that forces of friction make it possible for objects to stay in place and not to slip. With this in mind, we can say that work can be done by friction. Frictional work is important because without it, doing any kind of work is impossible. In our study, the phrase work done by friction denotes the effect of frictional force or the work of friction on mechanical energy. Let us now calculate work done by friction when a force is applied to an object. If the coefficient of kinetic friction between a sled with mass 40 kilograms and the snow-covered ground is 0.2, what is the work done on the sled by friction if a person pulls it over a distance of 5 meters with a force of 120 newtons at an angle of 0 degrees with the horizontal? What is the net work done on the system? Let us draw a free body diagram for this problem. In this diagram, we would see that to get the work of friction, we need to find the magnitude of the kinetic friction, the coefficient, and the normal force. Using Newton's second law, we can solve for the normal force. Summation forces at y is equal to 0 is equal to n minus mg. Knowing that Fk is equal to mu k times n, we can now solve for the frictional work by using the equation the work of friction is equal to negative Fk delta x. W, or the work done by friction, is equal to negative Fk delta x, which is equal to mu k and delta x, which is equal to 0.2 times 40 kilograms times 9.8 meter per second squared times 5 meters. That would give us negative 392 joules. Let us now calculate the net work. The work applied is equal to force multiplied the distance delta x is equal to 120 newtons multiplied by 5 meters is equals to 600 joules. The work normal and the work of the gravity are 0 because they are not parallel to the direction of the displacement of the object. Therefore, W net is equal to the work applied plus the frictional work, the work of the friction, plus the work of the normal force plus work of the gravity. That would give us 600 joules minus 392 joules is equal to 208 joules.